Hello everybody and welcome to this video. This is a full analysis of a rational function. Okay, so what we're going to talk about here, we got quite a bit of stuff. First we're going to label, we're going to talk about vertical asymptotes if there are any. We're going to label any holes if they exist. We're going to find zeros if they exist. We're going to find Y-intercept. And then we're going to talk about the, it's called the end behavior. And I'm trying to think if I missed anything there. I don't think so. I don't think so. So let's jump right in. Okay, so vertical asymptotes, holes, and zeros are very easily determined and analyzed with the factored form. Okay, so I'm going to factor the numerator and denominator here. Okay, so let me start with the numerator. So these are quadratic trinomials. So 6 times negative 3 is negative 18. And I need to think of two numbers that multiply to negative 18, but add to negative 7. And that's going to be negative 9 and positive 2. All right. So negative 9 plus 2 is negative 7, and negative 9 times positive 2 is negative 18. I'm going to divide each one of these by the coefficient of x squared, which is 6. And I'm going to reduce if I can. So the first one is going to reduce by a factor of 3. So negative 3 over 2. And then this one's going to reduce by 2. So 1/3. Okay. There we go. So that's, so 2x minus 3, 3x plus 1. Now, okay, let me go ahead and write it the factored form. So 2x minus 3 times 3x plus 1. There's the numerator. And now in the denominator here, the first thing to notice is that there's a greatest common factor of x, leaving 10x squared plus 3x minus 27. Okay, so there we go. Now what's left is a quadratic. So just like we factor the numerator, we're going to factor the denominator. There's no greatest common factor numerically, so we're forced to take 10 and multiply by negative 27. 10 times negative 27 is negative 270. Big number there. And we need two numbers that multiply to negative 270, but add to positive 3. Okay. So for big numbers, it's okay if you pull out just a regular calculator here. And again, so what I'm going to do, if I'm not sure, I'm going to take 270 and I'm going to start dividing it by numbers, okay? Now, if I divide 270 by 2, there's no way that 135 and 2 is going to combine, is going to add or subtract to give me 3, okay? So that's not going to work, okay? So if you think about it carefully, you'll realize that the two numbers have to be near each other, okay? Because they have to add up to 3. And that's only going to happen if the numbers are 3 apart from one another, okay? Well, that is if one's positive and one's negative, okay? And that has to be the case. It must be the case that one's positive and one's negative because the multiplication result is negative. Okay, so I'm going to start taking a 270. I'm going to divide by some bigger numbers, right? So 10 is a bigger number. 10 and 27. However, 27 minus 10 is 17. So that's not going to work either. So I need to try something bigger than 10. So 270. Let's try 12. Let's see if 12 works. 22.5 doesn't go evenly. That's not going to work. 270. I know 13 and 14 is not going to work. Let's try 15. All right, so 15 and 18. So these two numbers are 3 apart from one another. So I think we found our two numbers. All right, so we want these to add to a positive 3. So we're talking about positive 18 and negative 15. All right. Then, just like we factored before, we're going to divide each one of these by the coefficient of x squared. So we're going to divide each one of these by 10. And we're going to reduce if we can. Okay, so 18 over 10. That's going to reduce by a factor of 2 to 9 over 5. This is going to reduce by a factor of 5 to negative 3 over 2. Okay. Bottom number is our number in front of x. So this becomes 2x minus 3 times 3x plus 1 over, we got x hanging out, and then this is 5x plus 9 multiplied by 2x minus 3. Okay, so now this is completely factored. So now we're finally ready to start talking about asymptotes and holes and all that. Okay, so for vertical asymptotes, let's remember that the vertical asymptote is going to occur when the denominator is able to get very, very small and the numerator stays normal. Okay, so basically we're looking for factors that are in the bottom only. So 5x plus 9 is only in the bottom, and also this lone x is also only in the bottom. Okay, so we have two factors down here that only appear in the bottom. Now 2x minus 3 on the other hand, 2x minus 3 appears in the bottom and the top. So because the multiplicity is the same, in other words, because these factors cancel out completely, this is not going to give me a vertical asymptote. Okay, 2x minus 3 is going to give me a hole. All right, so finally that's off. That's good. So we're going to have a vertical asymptote. The unique bottom factors. So the first factor here is x. Set that equal to 0. And then we also have 5x plus 9. Set that equal to 0. Subtract 9 divided by 5, minus 9, minus 9. We get 5x equals negative 9. Divide both sides by 5. Ooh, sorry about that. And x equals negative 9 over 5. Okay, so there we go. Two vertical asymptotes. One is at 0. One is at negative 9 over 5. Okay, so there we go. Vertical asymptotes are done. Okay, now, well, I'll tell you what. Let's do the holes and everything else first, and then we'll come back to vertical asymptotes. We have some more to talk about with vertical asymptotes. And what I'm going to do is I'm actually going to leave a little bit of space just so we can talk more about vertical asymptotes later. Hopefully that's enough space. I'm hoping this is enough space. So here's our vertical asymptote discussion right here. Okay. All right. So there we go. We found our vertical asymptotes. Now let's find any holes that exist. And I've already mentioned that we have 2x minus 3 is a factor in the top and the bottom, and the exponents or the multiplicity on these is the same in the top and bottom. So these are essentially going to completely cancel out, except for where 2x minus 3 is 0. Okay, so for our holes, we're going to have 2x minus 3. We're going to set that equal to 0. That's going to be where our hole is. Add 3. 2x equals 3. Divide by 2. Divide by 2. X equals 3 over 2. Okay, so that's the x value for our holes. Okay, excellent. Now, very quickly, the zeros. Okay, so the zeros are kind of the opposite of the vertical asymptote. Okay, so for the zeros, we're looking for factors that are in the top only and that are not in the bottom. And here we are, 3x plus 1. This factor is in the top only, and it is not in the bottom. Okay, so for the zeros, we only have 1 this time. 3x plus 1 equals 0. Subtract 1. 3x equals negative 1 divided by 3. X equals negative 1/3. All right. So there we go. There we go. All right. We've identified location of asymptotes, holes, and zeros. Now let's do that y-intercept. Okay. So y-intercept, the thing to understand about that is if you have a curve that crosses the y-axis, this is the y-intercept, and the thing to understand is that the x-coordinate is 0. Okay, so all you got to do is in your expression set x to 0. Okay, so now if we look at this one, it's easiest to use this form here. Okay. If I plug 0 in, I'm going to get 0 here, 0 here. I want to get minus 3. Okay, now let's look at the bottom. The bottom is important. I'm going to have 0, 0, 0. In other words, I get division by 0. Okay? So again, if I do f of 0, I'm going to get negative 3 on top, and I'm going to get 0 on the bottom. Okay? And we cannot have 0 on the bottom. So what this means is that there is no y-intercept. No y-intercept. Okay? So there we go. We've identified where everything is. Now let's have a more in-depth discussion about these vertical asymptotes here. So when we have a vertical asymptote, that means our function is going to plus or minus infinity. Okay, let's look at negative 9 over 5 first. Okay, so negative 9 over 5. Let's think about that. Actually, you know what? I'll take that back. Let's do 0 first. Let's do 0 first. Okay. Now, what I want to do is I want to identify I want to find the left-hand limit, the left limit, and the right limit. Okay. Now, since I know this is a vertical asymptote, I know I'm going to get plus or minus infinity. I just have to figure out which one. Is it negative from the left, positive from the right, or is it the other way around? Or are they both negative? Are they both positive? Okay. This could happen. Okay. So what I'm going to do, I'm trying to calculate the limit as x approaches 0 from the left of my rational function. And then separately, I'm trying to calculate the limit as x approaches 0 from the right of my rational function. That's what I'm trying to do. And the way I'm going to do that is I'm just going to plug in a number really close to 0. So I'm going to plug in like negative 0.001. Okay. If I plug that in to my rational function, I'm going to use the factored form, which is literally right here. Okay. And what I'm going to worry about first, I'm going to worry about if this is positive or negative. So 2 times negative 0.001, that's definitely a negative number. If I subtract 3 from that, it's still going to be negative. So what I wind up with is a negative times, now, 3 times negative 0.001, that's a tiny negative number. If I add 1 to it, that's going to make it positive, okay? 3 times 0.001, that's going to be like negative 0.003. If I add 1 to that, it's definitely going to be positive, okay? Over, now here's x by itself, so that's definitely a tiny negative. So let's do that. Let's actually put a tiny negative. Tiny negative, okay? Now here, 5 times negative 0.001, that's going to be negative 0.005. If I add 9 to it, that's going to be positive. And now, last but not least, this one's going to be exactly the same as this one, okay, because of the exact same factor. I don't even have to think about it. Negative, okay? So, overall, I have, let's count, let's just count, right? Let's just do this. Negative times a positive, that's a negative. Over negative times a negative, that's positive. Okay? So negative over a positive, that's a negative. Okay? And because this one's teeny, teeny, tiny, and the rest of them are not, then we are talking about negative infinity for this limit. Okay? So this limit is negative infinity. All right. Now you can probably guess what's going to happen here if I plug in like 0.001. If I plug in the positive version. Okay, let's think about what would happen. Let's compare the factored form. Here it is. Okay. By the way, what we can do. Actually, never mind. Let's not do that. Well. Yeah, so because 2x minus 3 is common to both, the only place that really matters is here at 3 over 2. And we're not dealing with that right now. So what we can do, we can make this thing easier if we cancel these two factors. Okay, so here's what I'm going to do. I'm going to write c of x over here for the canceled function. Okay, I'm going to put my canceled function over here. So this is going to be 3x plus 1 over x times 5x plus 9. All I did was cancel the 2x minus 3's. This is what's left over. Okay, this is going to make it a lot easier. I'm going to get the exact same results because these two are exactly the same except where the hole is. Okay, anyway, let's do this. 3 times 0.001 plus 3, or I'm sorry, plus 1. That's definitely going to be positive on top. And now 0.001, that's a tiny positive. It's the presence of these tiny numbers that sends us to infinity. Okay? Now, 5 times 0.001, that's 0.005. If I add 9 to that, that's going to be a positive number for sure. So there we go. We get a positive over a tiny positive. So that's our plus infinity. Okay, so there we go. All right, now let's do the same thing for negative 9 over 5. Okay, so what we can do is we can pick a number really close to negative 9 over 5. And I'm going to make this easy on myself. I'm just going to do 9 over 5. 1.8. Okay. So I'm going to pick a number really close to 1.8 to the left and to the right. Okay. So in other words, I am evaluating the limit as x approaches negative 9 over 5. Let me make sure I'm not messing that up. Yeah. Negative 9 over 5 from the left of my rational function. And then separately, I'm going to identify the limit as x approaches negative 9 over 5 from the right of my rational function. Okay. All right. And now to do this, I'm going to plug in a number just to the left of negative 1.8, which is like negative 1.8001. And here, to find out what's happening here, I'm going to plug in a number like negative 1.799. I'm just trying to see what happens in the neighborhood of where it's undefined. All right, now again we're using the factored form, and again we can actually use the canceled function here. Okay, so 3 times negative 1.8, definitely going to be negative. If I add 1 to that, it's still going to be negative. Okay, so I get a negative on top over negative 1.8001. If I just plug it in here to x, that's going to be negative. And now here's the most important part. Okay, negative 1.8001 times 5. Well, that's going to be barely more negative, technically barely less than negative 9. This is going to be like negative 9.005. Let me convince you of that right now. If I do 1.8, I'm sorry, let me actually do it, right? 1.8001, and then I'm going to multiply by negative 1. There we go. Okay, so there's that, and now I want to multiply this thing by 5. That's not what I meant to do. I hate this calculator. Let's forget about the sign for now. 1.8001 multiplied by 5. Once again, that's not what I'm trying to do. So sorry, everybody. 1.8001. If I multiply by 5, I'm going to get a number barely bigger than 9. Okay, 9.005. All right, except it's going to be negative. Negative 9.005 plus 9. That's a tiny negative. Okay, so negative over negative is a positive, so we get a positive over a tiny negative, which is going to be a huge negative, which means this is going to be negative infinity. Okay, and here, let's use the same reasoning. 3x plus 1, 3 times negative 1.8 plus 1, that's going to be a negative on top. Negative 1.799, that's going to be a negative down here. And then times, now 5 times negative 1.799, that's going to be like negative 8.99 something, okay? When I add 9 to it, it's going to give me a tiny positive. Tiny positive. Okay? And so this overall is going to be positive, so we're talking about positive infinity here. Okay, there we go. So there's all the left and right hand limits for the vertical asymptote. Okay, let's see what else we got. Let's find the y value of the whole. Okay, so we know the x value of the whole. The x value of the whole is 3 over 2. And to find the y value, all you got to do is plug this into the canceled function, the c of x here. Okay, so y value of whole, let me write c of x again. 3x plus 1, so c of x is 3x plus 1 over x 5x plus 9. All right, x value of the whole, we got a whole at x equals 3/2. I'm going to plug that into my function, and I'm going to find the y value of the whole. So I'm going to get 3 times 3/2 plus 1 over 3/2 multiplied by 5 times 3/2 plus 9. All right. 3 is the same as 3 over 1. 3 over 1 times 3 over 2. 3 times 3 is 9. 1 times 2 is 2. And then plus 1. Plus 1, but I'm going to need a common denominator. 1 is the same thing as 2 over 2. All right, this is just going to save me some work. All right, divided by 3 over 2 multiplied by 5 times 3 is 15 over 2 plus, and now plus 9, but I can see I need a common denominator. So 9 is the same thing as 18 over 2. All right, that's just going to make this take less steps. 9 over 2 plus 2 over 2, that's 11 over 2, over, and then we get 3 over 2 multiplied by 15 plus 18, that's 33 over 2. And what do we get? 11 over 2 over, and then here we go. 3 times 33 is 99. Over 2 times 2 is 4. Okay, now we have a fraction over a fraction. We can play the complex fraction game. So keep, change, flip, as you all like to say. 11 over 2 multiplied by 4 over 99. Okay, and what's going to happen here? 4 over 2, that cancels, leaving just a 2 up here because 4 is 2 times 2. And then 11 and 99 are going to cancel, leaving just a 9 down here because 99 is 11 times 9. And so what we wind up with is literally just 2 over 9 as the y value for the whole. So whole is at x equal 3/2, y equal 2 over 9. All right, so there we go. We got our left and right hand limits for our asymptotes. We got the x and y value of the whole. We have our 0. All right, so we are getting there, everybody. Do we have the Y-intercept? I don't think so. Y-intercept, did I calculate that? I really don't think I did. All right. Let's do the Y-intercept, everybody. So for Y-intercept, once again, I got this little thing here, x equals 0. All right, so Y-intercept. And the easiest way to find the Y-intercept is actually with the expanded form, not the factored form. So let me come up here to the, oh, whoa, I forgot. I totally already did the Y-intercept. No Y-intercept. Oops. Memory is not the best. There's a lot of stuff in this problem. Give me a break. All right. Y-intercept done, zeros done, holes, x and y value, vertical asymptotes done. End behavior, okay? End behavior is what happens when x goes to plus or minus infinity, okay? And end behavior is done best with the expanded form. This one right here, the thing we started with. So let me write that down again. So this is for end behavior. All right, so once again, our rational function is 6x squared minus 7x minus 3 over, and then we get 10x to the 3 plus 3x squared minus 27x. All right, so here's what we need. We need the limit as x approaches positive infinity. And we also need the limit as x approaches negative infinity. Okay. And here's the strategy for this, everybody. Okay, the strategy is you're gonna find. Here's the strategy. Find highest power term. Find highest power term in the denominator. And then factor factor this from top and bottom. Okay, so in the denominator, my highest power term is x to the 3. I'm going to factor x to the 3 from the top and the bottom. Okay, so if I factor x to the 3 from the top, then I got to be careful because there's only 2 of them here. So I got to play the division game, right? So this is, so first I want to write it like this. 6x squared over x cubed minus 7x over x cubed minus 3 over x cubed. Okay, over, I'm going to factor in x cubed from the bottom as well, leaving 10, well, okay, 10x cubed over x cubed, which is just going to be 10, plus 3x squared over x cubed minus 27x over x cubed. Okay, and so now we've rewritten the problem because here we have x cubed over itself. X cubed over itself is nothing. Okay, and so we wind up with the limit as x approaches infinity of everything left here. Okay, now let's do some algebra. X squared over x cubed, well, that's just going to be like this. That's going to be 6 over x minus x over x cubed, that's going to be 7 over x squared, minus 3 over x cubed. And then this is divided by 10x cubed over x cubed is just 10, plus 3 over x, minus 27 over x squared. All right, everybody. So now, here's the thing. X is going to infinity. X is going to infinity. We have an x on the bottom, okay? So we're dividing by an infinitely large number. And if we divide by an infinitely large number, that is going to go to 0, okay? So here's the point. Here's the point. This term goes to 0 because there's an x in the bottom. This term goes to 0 even faster because there's 2 x's in the bottom. This term goes to 0 even faster because there's 3 x's in the bottom. All we have left on the bottom is a 10 because plus 3 over x, this goes to 0 as x goes to infinity, and this goes to 0 as x goes to infinity. So altogether we wind up with 0 over 10. 0 out of 10, that is just going to be 0. Okay? And you can repeat this analysis for negative infinity, and you're going to get exactly the same result. Okay, so because the result's exactly the same, I'm not going to go through that. You do it the exact same way I just did this one. Okay, excellent. So now, what does this mean? Let's plot this thing. Let's use this information to generate a graph. All right, so come over here. Okay, so there's my XY grid. And now let's label vertical asymptotes. Yeah. So vertical asymptotes are going to happen at 0 and negative 1.8. Okay. So 0, that's the x-axis, and then negative 1.8. Let's say this is negative 1. Let's say this is negative 2. So negative 1.8 is about here. So this little dotted line represents my vertical asymptote. And then I would put a dotted line over the y-axis, but you wouldn't be able to see it. I guess what I'll do is I'll put it in a different color. That's what I'll do. So there we go. There's a vertical asymptote. Now, y-axis is my other vertical asymptote. Okay, now let's put all this stuff together. So as we approach negative 9 over 5 from the left, we're going to negative infinity. Okay. Let's put the 0 here. Negative 1/3. Negative 1/3 is a 0. So let's plot that because we know that point exactly. Here's negative 1, so negative 1/3 would have to be right here. Here's negative 1/3. Okay? All right, everybody. So now, as we approach negative 9 over 5 from the left, we're going to negative infinity. So here's what this looks like. Negative infinity from the left, like that. Okay, now as we approach negative 9 over 5 from the right, we're going to positive infinity. Okay, so here's a 0, and then as we approach 1.5 or negative 1.8 from the right, we're going to positive infinity. Okay, now we also have an asymptote at 0, which was the first one we talked about. So 0 from the left, negative infinity. All right, 0 from the left, negative infinity. Here's 0. Here's 0. So as I approach 0 from the left, I'm going to negative infinity again, just like this. Just like that. Okay, and then as I approach 0 from the right, let me go up here. As I approach 0 from the right, I'm going to positive infinity. Okay. So positive infinity like this. And then from our end behavior, as x goes to infinity, the function is going to approach 0 from both sides. In other words, 0 from this way, and then 0 from below this way. All right, so there is the graph that I've come up with. Let's check this with Desmos. Okay. Yeah, let's check this with Desmos. All right, let me enter this in. So this is going to be 6x squared minus 7x minus 3 divided by 10x to the 3 plus 3x squared minus 27x. And there we go. Exactly as we predicted. Okay. There's our graph. There's Desmos. Okay, so boom, done. All right. Hopefully that made sense. I know this has been a very lengthy video, but it's a lengthy thing to do. All right. So we used all this information to come up with a graph for f. All right.